Hey everyone, and welcome back. In this video we'll be looking at the SphereTrace in Unreal C++. If you're going through this as a playlist rather than individual videos, you've seen a couple of different trace topics that I've covered, and what I've been doing is covering the world context tracing, like line tracing and sweep tracing, and then also covering the Kismet version of the same traces, so the Kismet line trace, and this is going to be the Kismet SphereTrace. The main difference, if you're not familiar, is that the ones you find in the Kismet library are the same ones that you'll be using if you are using traces in blueprints, and the benefits of using those are really good if you wanted to debug things as well and show them to screen, as the world context traces generally don't have the same kind of flexibility there. So to get started, as ever, we're going to go to our C++ classes. I'm going to be creating this as a component. Of course, you can add this in as an actor class or something if you wanted. But as you'll see at the end of this video, if you haven't followed the others, this is going to allow us to really easily just drop this onto any actor that may need to do a trace. So keeping things kind of segmented out as components can be really useful. So in here, I'm going to choose to create a new C++ class, and I've been using the scene component, and then I'm just going to name this one SphereTrace. That's all compiled for me, and I'm going to try a slightly different approach than some of the other videos that I've created. So take a look at some of my old content, compare it against this, and see what you prefer in the way that I'm about to go through the code, and let me know which you prefer. So basically, I would usually type through what I'm adding into the code as I kind of explain what it's doing. Whereas in this video, I'm just going to try out a new thing where I've already added all of the code to the class, and I'm just going to go through step by step and show you what it's doing and why we're adding it. And hopefully this will give you a little bit more time to read the code as it's on screen. It means you can pause this at any time and double check any of the code, which will make up the kind of entire function. So hopefully it's a little bit easier for you to keep up with. And it also means that because I'm using this presentation mode, it can be a little bit hard to type with the text quite this close. So when I'm typing, I would naturally be using something at this size. Everything then you can see kind of fits on screen better, but that will make it very hard for people to read the text depending on the kind of resolutions, or just in general it might be harder for people to read the text like this. But typing things out in the presentation mode, I have found I kind of forget things, haven't noticed that things haven't been included because it's been on screen. So hopefully this is going to be a good medium for the approach. Okay, so the first place I want to start is in the header file of the class that we've just created. I've only added one thing, and that is just down here in the public section. I've created a float variable named traceRadius, set it to 500 units, and provided this a uProperty of edit anywhere, and the category is set to trace. So this is just going to expose this in the editor, put it in a category named trace, and this will be the entire radius of the sphere that we're going to be using as our SphereTrace in just a moment. And exposing it in this way just makes it very easy to update this and change the variables to try different trace sizes. Then over in the code file, the first thing you need to be sure to include is the Kismet /Kismet system library.h. So like I've said, we're going to be using this function from the Kismet library. And then I've just noticed, so give me a second here, I'm just going to copy everything that I have in the tick function, and we only want this to be done once on the begin play. So I'll just paste that in there in case you noticed that that was currently being done on the event tick, and that isn't going to be ideal here. So to begin then, the first two variables that we need to create are going to be the start and the end location for our SphereTrace. I've set these both to be constant f vectors as the variable type isn't changing, one named start, one named end, and these are both returning the same thing, which is the getOwner function, and then from the owner, the getActorLocation, because we're intending to place this component onto an actor in the world. So the component itself doesn't have a location representation, or it does, but we're just going to use the actual location of the actor that it's placed on instead. And both of these can be the same because unlike a line trace where you're going to have a start point and an end point, I want this to be just a standard sphere. So the radius will be controlling the distance that this is tracing. If you were to add an end offset, you end up essentially getting two spheres, one at the start point and one at the end point, and that's not really what I'm going for. And all of these things that we're creating now are going to be used in the SphereTrace function in just a moment, so some of these are a little bit easier to create ahead of time. The next of those is a T-array of actors named actors to ignore, and obviously that's just going to be which actors not to trace against. And then just below that, I've called the actors to ignore.add, and then the getOwner function. So this is going to add the owner of this component, so the actor that this is placed on, to the array of things not to trace against. And then finally, before calling the SphereTrace function, I've created another TArray of type fHitResult and named this one hitArray. And this will be responsible for storing all of the information returned from the trace, such as what's been hit, the location that it was hit, the rotation, things like that. Okay, so moving down, we have the call to the SphereTraceMulti, which is being done on the Kismet system library. This is, I'm storing this as a constant boolean, and I've called this one hit. So again, we can use this information. The sphere traces, or any or most of the traces, return a boolean type as the function return type. The first thing that this needs when we are calling the function is a world context, so we're going to use the getWorld. It then wants the start and the endpoints, so I've got the start and the end value. Like I've said, they're the two vectors that we've created just above. It then wants to know how large to make the trace or the sphere, so that's the trace radius. And then we can choose which channel to trace against. So I've used the UEngine types, convert to trace type, and I've used the ECC_camera type here. Next, we get the option to set whether we want to use complex collisions or complex traces. So for things like tracing against objects with high detail or custom collisions, I've set this to false because I'm just going to be using very standard geometry, so spheres and cubes. We can pass in the actors that we don't want to be traced against, which is going to be our actors to ignore array. And then we're going to start getting into the visual side of things. So we can choose the eDraw debug trace, and this is going to be how long or if we want this to show information to the screen. So this is the main reason that we're using the SphereTrace, is because we get that visual feedback so we can debug things. So I'm going to set this to be for the duration, and we'll be specifying the duration to trace in just a moment. Then we will use this to fill in the information. So for every actor that we hit, we can fill our array of hit results. So we're going to pass in the hit array. We can also set this to ignore ourself, so the component itself, set that to be true. And then we have our trace color. So this is going to be represented if we hit something. I've set this to be an F linear color of gray, and then the trace hit color, and I've set this to be blue, again using the F linear color. And then going back to the draw debug trace for duration, the draw time I've set to be 60 seconds. So it's going, the duration for that to be drawn will be the 60 seconds. Then going down just a little bit further, I'm going to use the Boolean hit result that we've taken, so the one that we've got from our SphereTrace. Remember, I've called that hit, so we're saying that if we've hit something, if hit, then I'm going to go through a for each loop. And for the fHit result, which I've named hit result from the hit array, so for every hit result in that array of hit results, what I'm going to do is print some information to the screen using the GEngine, add on-screen debug message, and I can see here this is actually taking up too much space, so I'll drop that one down. And the information we're going to display, we're going to pass in a unique key of -1. The time to display this, I'll set this to be the same as the time to display the actual trace itself, so we'll set that to 60 seconds. I'm going to set the text color to orange using the F color value, and then the debug message itself is going to be an F string, printf, using the text macro. And I'm just going to print out the word hit with a double colon, and then we're using the %s to specify that this will be followed up by a string result which is being passed in, so like a dynamic kind of message here. And that will be the pointer of the hit result.actor, and then using the getName function, so getting the name of all of the actors that we're going through that the SphereTrace may have hit. Okay, and that is everything. So with all of that ready to go ahead and compile that, and then I'm just going to head back over to the engine. So with that done, back in the Unreal Engine, I'm just going to go to the content folder and the blueprints folder, and then inside of this I'll create another new actor, and I'm keeping all of these separated out so that I can upload the project files for the Patreon supporters if you are following along as well. And then you can download the project as I go along to get the example code, and everything's kind of separated out into the classes of the specific topics I've been covering. So for this I'm going to create a new actor blueprint. I'll name this one BP_SphereTrace. And inside of this class, all I've been doing is we add a component. I'm going to look for the new SphereTrace component we've just created. So we can see here, it's a custom object, which is the SphereTrace. Place this anywhere onto our actor. And then with that compiled and ready to go, I'm just going to remove the previous demo from the last video, drag in a SphereTrace just between these two objects. So these are going to be the objects that I'm using to demonstrate something being hit. Note here that I'm playing this in simulate, not selected viewport, so that I can see the entire viewport and not be dragged in to possess the default pawn in the world. And there we go, we can see our 500 radius sphere being traced. It's found the floor, cube 2, and sphere 5, which are these. And from the debug information, we can actually see our grey spheres. So these are overlaps, and we can see exactly where these overlaps are taking place on these grey spheres. And like I said, the really nice thing about this, the way that we've exposed things, if we go to our SphereTrace, we can set the radius to be bigger. So we can maybe set this to 1,500. And again, if we simulate, we're going to get a bigger sphere. There's nothing else here to hit, but if there was, it would trace further around and find those objects as well. So hopefully that's been useful. Hopefully that's shown you everything that is involved in using the Kismet version of the trace library instead. If you weren't familiar with the sweep trace, maybe go back and check that video out, because like I said, these don't really follow along, but it's useful to have the context of what the difference is. In the sweep trace option, we actually needed to manually draw debug spheres and things to represent the debugging of the trace, because the world context function doesn't have those options, but it is the more commonly used function if you're just trying to get the information back and maybe not display it. So I just wanted to give those two comparisons. And also do let me know what you think of the new approach with the code, having it all ready and just going through step by step. Hopefully that's going to be more useful for people, apart from the explanation that I kind of needed to add in of why I was doing it. The idea is that it will make the videos flow faster and be a bit more intuitive as well. So let me know what you think about the new approach in the comments down below. If you like that, I'll keep doing it in the future videos. If for some reason that I haven't considered it's very off-putting or weird, then I'll just go back to typing things out as I'm explaining them and kind of get used to typing it on a much larger text display, but that would be fine. As I mentioned, if you're supporting me on Patreon, you'll have access to download this updated version of the project immediately. I've probably updated you before this video has gone live. So a big thank you to everyone supporting me over on Patreon. If you wanted to look into doing that yourself to help support the channel, get some access to additional files and projects like this, then do consider checking the link out in the description below. Otherwise, if you enjoyed the video or found it useful, please do leave a like and share the video around. That really helps the channel and is greatly appreciated. As ever though, thanks for watching, and I will see you all next time.